Okay, so as per the question, we have been given a circle and then we have a triangle, as you can see. So A, B, C are the vertices of the triangle and I is the incenter. So, okay, so never confuse circumcenter with the center of the circle. Okay, so here it is different. Here it is incenter. And you know how an incenter is formed, isn't it? That is the point of intersection of the angular bisectors of the three angles of a triangle. And geometrically, what is its significance? This point I, that is incenter, is equidistant from each of the three sides. That is, we can draw a circle which touches all the three sides. It will be inside. Okay, the circle will be inside the triangle. Okay, now that is given to us. So, one thing we can infer, that is, we are also being given other things, isn't it? BAC. What is BAC? I'm just going to mark that out here in a different color. See, BAC, I'm marking it here. Angle BAC is 55 degrees. Okay, in green, I'm marking it now, as you can see. That is given to us. Angle ACB. ACB is, this is B. This is point B. So, angle ACB is 65 degrees. That also I'm marking here, as you can see. So, we have been asked to find angle DCA. DCA. So, I might as well see, I'm going to join D and C. It's not given in the question. This is my construction. So, I'm just going to draw it with dotted lines. Okay. So, I'm going to, I'll just draw it. Wait. So, I'm going to join D with C. Okay. D and C. You can see that. We're going to use the properties of circles and triangles here. So, now we look at the red triangle, that is triangle ABC. So, let me apply angle sum property there. In triangle ABC, 55 degrees plus 65 degrees, we have marked that, isn't it? It's given in the question. Angle BAC is 55 degrees, angle ACB is 65 degrees, plus angle ABC is equal to 180. So, 55 plus 65, 120 plus angle ABC will be 180, which means angle ABC will be 180 minus 120, which will be 60 degrees. Okay, that is what we infer. We have got that. That complete angle B will be 60 degrees. I'll mark it here, see, 60 degrees. Okay, 60 degrees. I found that out. Now I want angle DCA. So, if you look carefully, you see angle DCA, I'm marking it in I am marking angle DCA. See, I'm going to mark it with two black strokes. You can see here, isn't it? So, angle DCA. Now, see that you look at points A and D. Just focus on that. A, comma D, you're joining it to C. You're getting angle DCA. And the same A and D, look carefully, you're joining it to B. Now, angle B is what? Angle ABC rather. Angle ABC is 60 degrees. So now BI is an angular bisector, isn't it? BID. I is a BID are collinear points. I is lying on BD. So if you observe here, I can say that angle ABD will be equal to angle DBC, which is 60 by 2, which is 30 degrees. Because I is the point of intersection of the angular bisectors. So this will be 30. So I'm marking it out here, and this will be the other 30. You can see here 30 degrees, isn't it? So now look back. I told you A and D are joined to C, A and D are joined to B. So I can say angle DCA, which I marked in double strokes, will be equal to angle ABD, isn't it? Angles in the same segment. It is like this. If you can, if you are able to visualize, I'm just drawing it out for you for a better perspective. See, you can see here A is there, and there is D, and there is C, and there is B. So this angle is equal to this angle, isn't it? So that is 30 degrees. So we found item number 1, that is angle DCA is equal to 30 degrees. Angle DAC. Angle DAC. So what I can do is I can join A to D. Okay. Again, if you look carefully, see, point C and D, you're joining it to A. And the same point C and D, you're joining it to B, which means angle DBC will be equal to angle DAC. Again, angles in the same segment, and that will be equal to 30 degrees because angle DBC is 30 degrees, isn't it? So, I mean, I didn't mention the reason earlier, no? For the first part, that is angle DC when we found, and even for this, the concept is, it is angles in the same segment. Angles in the same segment. Okay, so angles in the same segment. So we found angle DAC also. Okay, angle DAC. It's like this. So you have your, go back, it is DAC, D and C. So you have somewhere, you have D here, you have C here. So DAC and you have DBC. Okay, so you have to visualize it in that manner, and that's why it is equal to 30 degrees. Now come back, what else we did? DCI. DCI. Okay, join C to I. Okay, so when you join C to I, so you can see I have again put dotted lines here. C and I have joined. This will be what? 65 by 2. That is 32.5, isn't it? Because it's the angular bisector. That's why. So when I join C to I, this angle will be 32.5. And this, the other part, that is angle DCA from sub question 1, I found out. What is that? 30 degrees, isn't it? So I can say, I'm just taking you to the next page. Angle DCA, okay, angle DCA, we found out. No, we need DCI. Okay, angle DCI is what? Go back. Angle DCI is DCA plus DCA plus angle ACI, isn't it? Plus angle ACI. So now, so we found out what is DCI, isn't it? Angle DCI will be DCA plus angle AIC. So always go with that concept of angular bisector, okay? Because I is the incenter. So to find AIC, just remember this, angle at the center is twice the angle at twice the boundary angle. Yeah. So if you look back, your A and I are joined to, see, I'm just drawing a rough sketch again. Your A and I are joined, A and C are joined to I. The same A and I are joined to B. Isn't it? Go back, see, A and C are joined to I, and the same A and C are joined to B. So at B you get the boundary angle, at I you get the Okay, not this. We can't use this because I is not the center. Okay. Yeah, one thing we need to remember is unlike your circumcenter, where circumcenter is equal to the center of the circle, here it is not. Okay. So AIC will not be equal to, you can't use I as the center. We'll apply a different logic to find that out here. I'll just come to this. Okay, I'll just redraw the figure again. I have this. Okay, so you have AIC. I'll just draw those things here. So A, and there's somewhere down the line you get your I, and then you have C, isn't it? And then you have this B. I'm already drawing a rough sketch, and this is your C. Okay. All right. This is AIC. So the complete angle A is what? 55 degrees, isn't it? So that is angle BAC is 55. Angle ACB is 65. Yeah. So this entire angle will be this entire angle is 55 and this entire angle is 65. So because I is the in center, this will be 55 by 2. I'll not take in decimals, I just keep it at this. Likewise, this entire angle C will be 65. So this part will be 65 by 2 because I is the in center, isn't it? So now we can find out AIC. It's very tempting to, because the way it is located, it's tempting to, take up BD as the diameter and I as the center. Then we'll get something incorrect. It's not that way. Okay. So now you apply your angle sum property to this triangle AIC. You want AIC, isn't it? You want AIC. So AIC will be this, yeah. So to find in this triangle, what you do is 55 by 2 plus 65 by 2 plus angle AIC is equal to 180. So 60 plus 50 plus 61, 110 plus 120 by 2, that is 60, isn't it? 60 plus angle AIC is 180. Yeah. Angle AIC will be 180 minus 60, which is 120 degrees. In that case, we'll get this entire angle as 120 degrees. So we found out all of them, isn't it? We found DCA, we found DAC, we found DCI, and we found AIC as well. Okay. So hope the explanation has been clear.